Did you know that .NET Runtime can handle thousands of asynchronous operations at the same time without breaking a sweat? If you are interested to find out how it does it, or you're not familiar with these concepts that I'm mentioning, I think that you will really benefit from this video a lot, because you will have way more solid and core understanding about the underlying mechanisms that exist in .NET and C# in general. Greetings, dear friends, fellow programmers, and those aspiring to be. Welcome back to Marko Code Academy, a place where we are learning about asynchronous .NET and becoming true masters at it. So, as you probably could have guessed, in this video we are going to embark on a journey where we will be exploring the world of asynchronous .NET, and also along the way find out why it's so awesome and so crucial for our applications' amazing performance. No matter whether you are building web applications, mobile applications, simple console app, or Windows applications, it doesn't matter. Learning and mastering async coding will make you a great developer for sure. Understanding asynchronous programming will make you a designer of smooth experiences, because all of your applications will have smooth experiences for all of the users out of the box. Welcome to the heart of .NET Runtime, a place where your asynchronous code is being meticulously managed, ensuring smooth and effective experience. So, what are you waiting for? Let's get started right away and discuss all the mechanisms that we have to understand. In today's world, speed and efficiency are paramount. You cannot build anything that is going to be slow, freezing, or running into problems if you want to build a successful product that people will actually use. So you need a way to make this happen. Your application needs to handle multiple tasks at the same time without slowing down or freezing, of course. And that is exactly where asynchronous programming comes to the rescue, because it allows you to free up the main thread and allow your application to run smoothly without freezing, and also handle tasks that you gave to your application to perform in the background. The key to this magical behavior lies in the async await keywords. But if you want to truly understand how those keywords are making your code behave amazingly well, you have to learn about underlying mechanisms, and that is exactly what we will do in this video. To truly understand how .NET Runtime handles asynchronous tasks, we need to delve a bit deeper and see how it manages them and how they're being handled, treated, organized, and then basically sped out to the end user. Meet the task scheduler, the person who is a frontman of our factory. Basically, this is the mechanism that decides which task gets executed at which time. It works really closely with the thread pool, we will cover it very soon, and it does it so that it constantly communicates with the thread pool, picks up the thread that seems the best fit for the task it has ready for execution, and then it delegates it to the thread. And of course, it does it in such a fashion so it doesn't overwhelm the system. So what this means is that once we create a task in our code, it doesn't get executed right away. It is handed off to task scheduler, and then it decides what is the best time for this task to be executed. And basically, task scheduler does all the optimization on how and when to perform certain tasks, so we would achieve optimal resource utilization and minimum downtimes for our threads. Of course, that way allowing our application to be online and responsive even under very heavy load. And also, task scheduler does one more thing, and that is when our task is completed and all the operations that were supposed to be executed are executed, Task Scheduler manages what happens then with the task. It basically then decides what is going to be the next piece of code to be executed, and it also decides on which thread it should be executed, depending on the situation, of course. Behind every successful asynchronous operation lies a set of hard-working threads. These threads are also known as a thread pool. The thread pool is basically like an always ready to work workforce, always eager to work set of workers. They're just waiting for Task Scheduler to assign some work to them, and they're happily going to execute it. Thread pool is being managed dynamically by .NET Runtime, and what this means is that based on the workload, on the amount of work that needs to be done at a given moment, .NET Runtime decides how many threads should be in the thread pool in order to be able to adjust to the workload that we have at hand. This functionality and this smartness of .NET Runtime allows us to be able to handle those spikes in demand for working power to be handled very gracefully and without any hiccups in our application's performance. And also you should know that we do have the power to specify how many threads we want to have in our thread pool. But when we explicitly set a number of threads in the thread pool, we're opening ourselves to basically create issues, because having too many threads in the thread pool is also a very bad thing to have, and it will affect performance negatively. So be very careful, do your due diligence, and learn what is the optimal number of threads in the thread pool for certain specific situations, so you would be able to adjust your thread pool thread count accordingly. Now, let us take a deep dive into one of the most fascinating aspects of asynchronous programming. I'm talking about state machines. Every time we use a wait keyword in our code, we're basically instantiating and creating a new state machine that is going to take a snapshot of the current state of things in the method where the await keyword was seen. The state machine's job is to remember the state of things in our code at the moment when the await keyword was reached. So it would be able to return the state into that exact state when it was paused and be able to resume it from basically the same situation as it was when the state was paused. That way, making sure that basically nothing happened while the task was being handled by our threads. What this means is that state machine is going to remember the values that are being stored in all the local variables inside of the method where await keyword was reached, and it will save them, and also it will remember all the relevant states and the place where our execution stopped at the moment when our state machine was created, so that when our task is ready and completed, the state machine can return the values into all variables and let know where the execution should continue from. And basically, by capturing and resuming the state of methods, state machine allows our code to run asynchronously without blocking the main thread. And basically, this behavior is what makes async await so powerful. Because if there was no such abstraction as the state machine, we as people would have so much issues to follow the flow of execution in our asynchronous code that it would be very difficult to follow what is happening in our code. Because when we are executing asynchronous code, many things are happening at once, and things can get executed at different times that are not so logical to us. And the state machine is what is blurring the edges between synchronous and asynchronous code execution, making it much easier for us as developers to follow what is happening in our code. In In many applications, even more so those with user interface, it is so paramount that your task gets returned to the thread where it was invoked, so things could continue executing on the right and correct thread. And it would not be so easy to have this behavior and always know for sure that our task, once handled, will be returned to the correct thread to continue execution. But that is why we have our synchronization context, which ensures that this behavior is always in place. It is basically behaving as an invisible traffic controller for our tasks. Of course, if we did not have this mechanism in place, and some of our tasks would get started with their execution from the UI thread, and once completed, they would not be sent back to the UI thread but some other thread, we would end up having so many difficulties and our application would not run properly because the result would be sent to a place where it means nothing, and we do not want that. Which is why synchronization context is extremely important. The .NET runtime is a fine-tuned machine, but even though it is already built with all the underlying necessary mechanisms for providing us with capabilities to run asynchronous code, we as developers need to do our part as well. Because if we do not care and understand how things are getting executed behind the hood, we would not be helping .NET runtime and we would not allow things to run as smoothly as possible. Poorly designed asynchronous code can run into bottlenecks. It can run out of threads in the thread pool, or even deadlocks. And in those situations, your application will not run. It will just blow all over the place and stop working, which is not a very good user experience, which is why it is paramount for us as developers to learn everything that is happening in .NET runtime when we are using asynchronous code. And by doing that, we will know how to protect ourselves from potential issues that arise from using asynchronous code that is also being executed in a multi-threaded environment. But by watching this video, you, my friend, are on a very good path. And if you also stick around in the upcoming lessons, you will have absolutely no issues to make amazing asynchronous code and not run into issues when you run that code. So in this lesson, we learned a lot about underlying mechanisms that make .NET be able to run asynchronous code and make it run smoothly without any interruptions or problems along the way. If you enjoyed this video, I would like to invite you to subscribe to the channel because we're still going strong with the series about asynchronous code in .NET, and I think you should definitely stick around because a lot of very valuable lessons are on the way. Until the next video, thank you for watching and have an amazing day. Happy coding!